Oh,
Hi, and welcome to the April 2025 Houston Java User Group meeting, sponsored by Improving. Here at Improving, we have user group space available. We host groups like the Free Code Camp, Houston.NET User Group, the Side Project Society, Houston Project Community, Product Community rather, and then Houston Linux Group and Houston Java User Group. And we do have a calendar available on improving.com on the Houston office page. So if you have an idea for a user group, come talk to us, and we can see what we can help you figure out. And also, if you're looking for an opportunity to make a career change, we are hiring, and we'd be happy to get signed up for an interview. We're hiring for business development managers, account executives, .NET Java, and DevOps engineers, and Agile coaches as well. And we're also doing a lot of work in the AI space. So if that's something that's of interest to you, that is also something that we are interviewing for. And if you're looking to jumpstart your agility journey, Improving is the biggest provider in North America of Scrum.org training. And we also offer in-person and remote offerings for both Scrum.org and ProKanban.org trainings. And I have gone through the PSM1 and the PSPO1 courses. They're really good, very thorough, and I learned quite a lot. And I can call out any baloney that Scrum Master tried to pull. So very, very handy. And also, if you could take a moment to go ahead and register, that way we can see how many we know how many folks have attended the Houston Java User Group meeting, so we can continue to receive sponsorship from Improving and get free pizza. So definitely be very helpful. Take a moment to do that, and we can get you registered. Everybody got it?
yeah.
Okay. Great. Thank you. And this is not the door prize QR code. Scott will take care of that. So
Yes.
all right. That's it. Take it away, Scott. Thank you.
Okay. So yeah, as people show up or if they come in online, I will provide them with the link to the door prizes. But I got everybody here already entered, so we're good for that. Tonight we're very fortunate to have Bazlur, Rahman, and Syed Shaaf talking to us about Java and large language models, a hands-on guide, and we're really looking forward to it. So without further ado, I'll let the brilliant speakers take it away. Thanks, guys.
Awesome, thank you. Thanks for the introduction. So excited to be here and talk about Java and large language models. And yeah, both me and Bazlur, we've been at this for a while, and like any other Java developer, we've been trying to learn through it. So what we want to do is share that experience with you through a hands-on guide, and we'll share the code as well. So thanks again for inviting us. Let's just do this, that we can quickly introduce ourselves before we get into the details. So Bazlur, do you want to go first? You're on mute. Yeah.
Okay. Hey, so I'm Bazlur Rahman. Yeah, I've been actively mentoring, writing, and speaking at conferences around the world. I'm very passionate about sharing knowledge and helping the developer community grow. Apart from that, I'm a founder of Java User Group Bangladesh. I think I started back in 2013, and I still serve as a moderator. And I have a few editorial role. I serve as an editor at both InfoQ and Poj.io, where I write technical content related to mostly Java. And I authored a few books, 5 books in Bengali, and currently I'm writing one. I think I have finished it. I think it's going to be available in September with ORID. It's on modern concretes in Java. Apart from that, I work at a DNS Tech as a staff software developer. I'm a JakartaEE ambassador and a Java champion. That's about me. Shaaf, how
Cool.
about
Yeah,
you?
thanks. So, yeah, about me, well, I work at Red Hat for quite some time. I work with Java. If you heard about the Keycloak project, InfiniSpan, all of those, I've worked with them before within the space of a solution engineer as well as developer advocate. Yeah, and I've been Java developer a long time. I wrote my first line of code in 1996, so that's some time ago. Um, is my screen sharing, Bazlur, or
I'm not sure. I cannot see it. I can see you.
are you guys able to see the screen?
Able to see the first line of Java is in 1996 and all that stuff.
Okay, so you can see the screen. So Bazlur,
Yeah.
okay, cool. Yeah, so the
Okay.
presentation is there. Amazing. Okay. Yeah, you just scared me for a second. Okay, yeah. So yeah, I've been doing Java for a long time, and I also do, write for InfoQ, and I write blogs, etc. So yeah, so I do a lot of that. And for the last 2 years, I've been working with large language models, doing fine tuning. I'm a contributor to a project called Conveyor.io, where basically trying to migrate JakartaEE applications using large language models as well. So some interesting stuff, not for today's talk, but yeah, pretty interesting. And obviously, I also play cricket. So if you're in US, obviously you do baseball, and if you're from my background, then you know cricket a bit, right? So yeah, I coached that as well. Anyways, getting to the topic, we don't have a lot of slides, like you mentioned. We're mostly going to do hands-on demos here and go through the reins of that, how each and every aspect is. We are going to go through all the different things about prompting, RAG, MCP, and how you can bring all of these things together. But before we do that, just a little bit of context in terms of large language models. Systems, data, networks, all of them, they speak data. Today, all of them have structured or unstructured data. Our systems, mostly business systems, have a lot of structured data. There's a lot of unstructured data that comes in. So bringing all of that together and making sense of that from a traditional perspective can be difficult, right? But when we talk about large language models, they give us the possibility to process natural language, and that is quite a good thing for us, because we can use it in many use cases, not just a chatbot, but also for other things, like I mentioned, code modernization, details about spec to code, etc., stuff like that. So there's multiple use cases there. And because of the natural language, they also have the possibility to do things like analysis of sentiment. User experience could actually be improved quite a lot using large language models as well. Whereas on the other hand, obviously our systems, let's say, assume that we want to add a new function to our system, we would be looking at the traditional ways of adding APIs, etc. And that is also fine in most of the cases, but in some cases, if you have explosion of data and a lot of it, maybe why not just train it if it's your private data as well, right? So there's some questions just to poke around and think about, because obviously they're not the solutions, but they will be part of our solutions as we go on. And then when it comes to Java developers, I mean, we don't have a lot of expertise in AI in general. Like, there are 12 million Java developers across the world. So me and Bazlur, what we're trying to do is go, all these different places and give some nice ideas around what AI is and get you started. So so you can follow sort of the same journey that we also started as well. So large language models, sure, they're natural language processing, etc. But let's just get a bit more technical about what they really can do today. They can do translation, summarization, writing, right? You know, Q&A, so you can summarize an email, and then you can say, hey, I write an email, it's summarized. Now explain the summary. Somebody else receives it, they say, hey, explain the summary to me. So you kind of use AI on both sides of the front, right? And in a funny manner, but also in an interesting manner as well. The reasoning is pretty new as well, with reasoning models that we can also do some reasoning and research, etc. The background that comes for large language models is obviously coming from the transformer architecture, which comes from a paper which is called "Attention is All You Need," coined by Stanford originally as foundational models, right? And one of the interesting pieces that you will find in that paper, or in general, is that when large language models start to process answers and generate text, they basically are doing it in certain phases. But one of the things is that they're actually predicting the way they are generating the text as well. So it's a statistical thing, which means that many times that when we query a large language model, we don't get the same response if we query the model twice, right? So what does that mean, and how does it affect us as well? It affects us in many ways when it comes to testing our systems, when it comes to how we actually process output from these large language models. So there's certain techniques, etc., that we can leverage and look at as well, and we'll speak about those too. And then finally, when we look at large language models, they're all trained on a lot of data. And we could say words for now for simplicity, but you've probably heard the word tokens. And these are billions. I believe in GPT 3.5 was about 400 billion tokens, right? So so a lot of common crawl data set, etc., that was being used, that helps to kind of create the large language model. Another possibility, obviously, is that you can tune your large language models. And I've done some tuning, and I'm happy to share experiences if we get into approaches like RAG, etc., during the demo phase, where then we can get and discuss that even a bit more. But again, the sum of this obviously is that large language models are predicting the next tokens, and how do we actually work with that? So what is token? Token is not a word. Strawberry is not one word in token language. It can be multiple. And here you can see examples of words and subwords, and predictability could be one word, but it is two words. Unpredictability is three words. So depends on how we actually tokenize or our data that comes in. But then these large language models create these vectors of them, and that's how they are able to work efficiently in matching similarity and doing that as well. There's a nice book that I put in reference here. Obviously, this is a much larger topic, but there's a nice book about building large language models from scratch by Sebastian Raschke. So if you're really interested in getting deep down in implementing each and every part of it and learning, then this is a really good book from Manning that explains it as well. And as we look into the speak of large language models, we'll see that every time what we are doing is sending tokens to the large language models and receiving tokens as well. And how does that work, etc. I'm going to show that in the demo as well. So without further ado, I'm gonna stop sharing here. And we'll start jumping into the demos. Obviously, I haven't given you a full clarity of all the demos here, because we have like 10 different demos that we do, but we're just going to go step by step, building it from a simple chatbot, and then going into prompts and prompt engineering, and then going into tools and RAG, and then MCP, hopefully by the end of it. I don't think we can cover more than that today, but we're hopeful we can do, and we're happy to stay further if needed. So Bazlur, over to you at this point, if you can share your screen.
All right. Let me share my screen and let me know if you can see my screen.
Yes.
Okay, perfect. This is essentially I'm going to share our source code first. I mean, that's what I love. I mean, slides are awesome, but I guess code can talks. So I love more codes than slides, but obviously the slides were prepared by Shaaf. Those were amazing. Thank you for that. So here's the structure of our project. We basically prepared it in a way so that you can follow through. It's kind of a way we had in our mind that we'll do a workshop one by one. So we'll start from the very basics, and then gradually we add stuff and make it more advanced. So that's how we prepared it. So we're gonna start by step one. But before going there, this is where I want to land first, which is essentially a start.JakartaEE project where we created the initial structure. Over here, you can select some of the checkbox. For example, if you want to use Jakarta 11, you can select that, and you can also select the profiles, Java standard version, and runtime. And there are few runtimes over here. Open Liberty, we use Wildfly. We use JakartaEE10, and then you can provide your group and artifact ID, all those things, and then you can generate. If you click over here, and it will give you a structure the way Spring or an other starter project does. For example, Spring has Spring initializer or something like that, and many other projects, Quarkus, Helidons, all of them have similar starter projects. So that's how we started, and then on top of it, we keep on adding stuff. So initially, this is our structure over here. As you can see, it has a few lines of codes. We have a chat WebSocket over here, and then a few configuration, and then most importantly that we are gonna interested in, which is this class, which is LangChain services. So one thing I would like to share at the beginning, which is even though our project is based on JakartaEE, but we are heavily relied on Jakarta LangChain 4J library, which is essentially we're gonna demo. Most of the demo are based on LangChain 4J. It's basically abstract all the communication with a large language model. I mean, it's written in a way that pretty much you can communicate all the other major large language model out there. So yeah, so that's essentially it is. So before explaining the code, I can show you what we have done. This is the first we have a small UI over here. As you can see in the top, in the left bottom side, we have a button over here. If we click on it, it says it's a chat interface. Essentially, we can talk to a model. It can be OpenAI model. It can be Gemini, or any other models available out there. It can be Llama as well. Right now it's communicating with OpenAI. So let me see if I can make it larger. There is a button over here. And do you see the text, by the way? Otherwise, I can make it larger. Okay, so that's the part I can do. So over here, if I say anything, it will reply, "Hey, hello." I just put random word, and it says it replied something. Hello, how can I assist you today? So that's essentially a communication between OpenAI model, and to achieve that, we needed a few things essentially. I mean, obviously, to communicate from UI to backend, we needed a WebSocket, which is pretty basic, right? I'm not going to explain it because JakartaEE has a annotation over here. You can create a class and put an annotation server endpoint. That's your WebSocket. It's pretty handy. You don't have to do anything else. So that's essentially it is. But we have a method over here that's essentially communicate with these LangChain services. So when we receive the message from the UI, it sends the message to these LangChain services, and then when it gets returns some response, and then it sends the message to the remote again. So essentially, that's a communication through the WebSocket. So that's a basic step. I'm not going to spend time on it. But the main thing that we needed, which is essentially two libraries over here, which is LangChain 4j. This is the core one that has all this abstraction, and then we have also on top of it OpenAI abstraction. So each major AP, provider, large language model provider has this kind of additional extra libraries that helps to communicate with their specific endpoints. So that's two things we needed. And then over here, as you can see, we have a abstraction called OpenAI chat models, and that's it. So it provides a nice builder pattern. So you can provide, the API key and then model name. Essentially, that's two things we need. The rest of the things you can configure additionally. For example, you can configure temperature, other things. For example, top P, timeout, max token. I'll explain them in a minute. But essentially, we need two things. One is API key, which is you are gonna get from the if it is OpenAI, you go to the API platform and create one, and then the model you are going to use it. So essentially that's it, and then you can basically communicate with this, with this method, which is called chat. So if you send a text, it will return you a text. And over here, the communication is happening through the WebSocket. So if I write anything over here, it will go through this method, which is chat. So that's everything, abstract away. So we need only one thing over here, which is OpenAI chat models for this particular demo, but gradually we'll add a few more layers on top of it. So yeah, essentially that's it is. So here we have a few other configuration options. I created this configuration just to minimize the demo time. So we have a few model over here. Currently it is using GPT 4.1 nano. We can change it. And then we have also mentioned over here the temperature. Temperature essentially is the randomness. So the idea is the randomness of a model. When you ask something, it will definitely return something, right? But you can control the behavior by providing the temperature. For example, if it is 0.7, that means it's a moderate, it's a moderate temperature. That means it will not be wild, random result. It will not give us an extremely random result. It will try to be predictable, but if we want to increase the accuracy, we can reduce to, 0.2 or 1 or 0. But if we add, let's keep this 7 and then show you a demo. So what I'm going to do is I will ask to write something. For example, hey, can you write a hello world Java program? So as you can see, it's gave me a hello world program pretty quickly. Now, if I increase the temperature, let's say we're going to use 2. That's the highest temperature we can give. So it's a 2, and we're going to update it. And let's see if it updated. Okay, the configuration updated successfully. Now, if I ask the same questions, let's see what happens. So let's see. I'm going to copy and paste it again, and let's see what it returns. So it's taking a bit of time, and as you can see, it became wild. It's giving all sort of random answers, random things. So that's how we essentially control the randomness. And there are a few other parameters you can try. So for this demo, I think we'll skip to this point. I mean, we'll skip other arguments, but you can definitely try them. For example, timeout, essentially how long you are going to wait. The max token is like Shaaf mentioned, token mentioned about token. Token is essentially the currency, right? The amount of token you're going to use, the amount of money we're going to pay to the token providers, essentially the provider of LLMs. So you have to control the tokens. I mean, you don't want to use a huge amount of tokens rather. But you have to be at the same time, for example, to get a response, you have to make it useful. For example, I can show you a quick demo over here, right? I have given a 1000 max demo, but if I make it, let's say 10, and then update configuration, and let's say I'm gonna ask the same questions, it will not be useful at all, because it will cut the response to, it will keep the response to 10 tokens. So let's see. So as you can see, it says, hey, certainly here's a simple hello world, but then there is nothing else over there, because that's the number we are only allowed to use 10 tokens. So we have to be careful about that. So these are the configuration we can do initial for the initial setups. And yeah, that's pretty much the first demo. I'm gonna hand over to Shaaf for the next one. Next one is going to be about prompt, which is we can control the behavior further. So Shaaf is going to show you the next demo. I'm gonna stop sharing.
Cool. Let me see. Okay, share. Yeah, that's a good point with tokens, right? I was using one of the models with 7B parameters the other day, and I was smart enough to send it 5,000 tokens in one request, and it was like, hey, I can't process that kind of token, so my limit is only 4,096, for example. So that helps with what kind of model you're using. It depends, and then you can restrict your tokens as well. So I'm going to jump into prompts, and we'll just take a look at a little bit of prompt engineering. So let me just start up my backend here. We're using Wildfly as the backend, but similar to what Bazlur showed in the first step, we've sort of created these steps. Obviously, step 0 is the first step, right? So, and then step 1 being the prompts, we take the same sort of infrastructure or application architecture to kind of build on top of it. And if I go here on my localhost, just to show you similar screen that Bazlur just showed us, sort of similar chatbot as well. And we're just gonna take a look at that in a second, right? So let's say I have a personality called Poet or a prompt called Poet. And what it does is that you can see that it is actually talking in poetry. So if I ask it something like, could you write a poem about Houston Java user group. I hope this is big enough, actually. I didn't realize that. And then obviously it's going to come back with some nice poem. It says, Houston's the heart where quarters unite, Java flows like coffee. So yeah, well, it's good and positive, right? So great to know that it has something nice to say about Houston Java user group, right? And the way it basically is doing it is that if I look at this specific prompt that I have here, let me just make this bigger for you. So we have, yeah. So here you'd see that I'm using a system prompt, and the system prompt is defining the overall behavior of this application, which is saying that it's a professional poet. Your response should only include the poem itself, nothing else. And then, write a single poem about the topic. And topic here is the parameter as well. I could also add a parameter to lines here, but obviously our front end has to sort of provide that, which it doesn't do right now. But I could provide multiple parameters here as well, but I say, okay, provide it in less than 3 sentences, right? If I remove this, it's going to definitely get a lot bigger in this scenario as well. So that's how let's say a system prompt is behaving. But then if I want to look at some of the other things, what we've done is what you might want to do is that you might want to adapt different prompts or different system prompts for the same application, right? And this again is using JakartaEE, sort of similar structure as well. We have something called what we did was that we have this type called personality, and this personality basically has multiple types, which is casual chat, chain of thought, and I'll just go over them a bit. There's a prompt called Java Champion, movie summarizer, tree of thought, etc. So if you have any questions, by the way, that you want me to throw at the prompt, feel free to let me know as well. So if I look at, let's say, I switch on to a prompt which is something different. I put I'll take something like Java Champion. Let's do that. Change that to Java Champion here. The prompt changes, and this is happening through a REST resource that we have here called the personality resource, which basically is sending a request to the backend, and the backend knows, okay, what's the current prompt? I need to switch this to a specific personality, and it's just going to make a switch within memory and make the switch within the LangChain service as well, which is basically starting up with the right kind of personality that we've created from our sealed class as well, right? So we are able to kind of do this on the fly, and it's an interesting way to work with multiple prompts. But let's take a look at Java Champion, right? The Java Champion is a sarcastic sort of prompt, which basically says that it should be humorous as well. It should help Java users, and it should always return something like I'm the real champion, right? So let's say if I say something like, "Hey, what's up?" Not the best of the Java one, but you can see that it has some humor. Just hanging out in the digital ether, waiting for someone to ask me about Java. Most important thing since sliced bread. Well, I kind of agree with that, but to some extent. So it's going to provide that. Let's just ask a specific question, and if you have any questions, please drop them in the chat. I'll be gladly putting them in. So let's say you're right. Why do we need a singleton in Java, right? And then obviously it's going to go in and give us the answer, but it's also going to sort of give some humor to it, but at the same time always end with the statement, "I'm the real champion." And this is because the prompt has been defined as such, as you see, that basically is kind of forcing the output of this to happen like this as well. If we go into other things, we also have a casual chat prompt, which is basically just a simple casual chat, just talking about a specific topic. But we also have other things like chain of thought, so you could actually ask it, and it's gonna, kind of make changes. I could go into TOT, which is basically thinking, organizing, translating. So if I ask a question, it's going to start to divide that question into multiple forms as well. So let's take a look at some of the way this was done. Here you'll see that what we did was that we added the get personality method, for example, which is basically just taking all the different prompt classes that we have and just loading them in, right? And like I showed, pretty much similar to what Bazlur was doing in the simple chat, but a little bit different here, where we're basically just loading the class on the runtime with the AI services, so we know exactly which kind of prompt is being loaded. But then we have something called a model service, which is also able to change not just the personality, but now you can also change the different models. So if I go back here and I don't want to use Mini, maybe I want to use GPT-4. And I asked the same question, right? Or why do we need singletons in Java, right? So it's just gonna basically, oops, something went wrong. I think my subscription might not have that, but let's see. Maybe Yeah. So, yep. Okay, maybe just an error. So could be the WebSocket timed out while I was talking. So why
There's a quick question in the chat that you can,
job, right? I can't see the questions though, but okay, so here you see that even using a different model now, it's able to give some of those psychiatric answers. And obviously there are different answers. One of the things that you will see is that every time I'm asking the questions, it's not exactly answering the same thing every time, right? So there's some difference, and it doesn't know what I actually asked it before. So it also becomes a bit tricky when we start to do that with prompts. And I think in our next demo with Bazlur, we can look at that. But before I go, I just want to make sort of like a bit of a summary here. You want to define a system prompt within your system, which specifies a task that you want to do, right? And you want to set expectations from that, like in case of our Java champion, or in terms of the poet, we're able to give those different sort of expectations. If we want to have more reasoning sort of thing, we could give it a reasoning prompt, which will give that more. If we want to process code security, etc., or injections, we would give that into the prompt as well. So it'll be able to kind of work with that. The user prompt is mostly, it can do some of that similar context as well, but mostly used for input and correlating that with the actual system prompt as well. So that's how I would differentiate between the two prompts then when you're programming. One of the interesting things obviously is that structure your input and output. When you use a large language model, depending on your use case, if you're using an instruct model, the instruct model will be more specific. If you're using a chat model might be more chatty, so it might not return the same JSON to you. You might be running this on your own machine or on a server and using it in a private context, so it's not using one of these big vendors. So different LLMs will behave differently, and that's something you will need to kind of learn and try. Which also means that, let's say if I created a prompt on Llama 2.5 or something, and then 3.2 came out, and I just converted everything to 3.2, my prompt is not going to behave the same way. It's not going to behave the same way across all the different large language models as well. So this is really a trial and error where you will have to go through something like that to get deep into how you want to do that. But prompt engineering obviously has its limitations, and the limitations here are that obviously you're not able to save the memory, you're not able to come back to the same results. Let's say if you had a specific context that you were getting out of the prompt might not look the same on another large language model. So we'll speak about some of those things as we go further, like how we can control this. So Bazlur, I guess if you're there, we can jump into the chat memory as well.
All right, I'm back. So let me share my screen again.
All right, so I do have a quick question. So, can you guys hear me?
Yes, I think we can hear you.
Okay, cool. So I noticed when you present the system prompt for Java chunking personality, you use some markdown format, if I remember correctly. Does that make a difference when you format your system prompt?
It's not, I can't really hear you. I don't know if you can be a bit more closer, Bazlur. Maybe I'll share my screen once again.
Sure.
All right, so I come closer to the laptop. So I noticed when you, for your Java champion personality, in the system prompt, you use some markdown format, like Pong's use case system prompt. So will those markdown formatting make a differences?
No, it doesn't really make a huge difference, to be honest. I think I think there's some error here with some copy paste, but but no, it shouldn't make a huge difference
Okay.
to it. Unless there is specific around markdown that you are looking into. So that could make a difference, but generally it will not make a difference.
Okay. So, but I guess in this case, it will consume tokens. So it's just basically a waste in this case.
Yes, that definitely
Alright.
100%. This what I've done here was a waste. Yes, that I totally agree with, because yeah, that was just additional tokens we're sending.
All right, cool. Thank you.
You're welcome. I think there was also some questions I didn't ask, so I apologize for that. And in respect of time, I think I'm just gonna stop sharing at this point.
Okay. Can you see my screen?
Yes.
Okay. So I just tried these few questions over here. It's just it answered the way it's supposed to. So I'm gonna skip it, but yeah, let me go into my next demo. So essentially over here, as you can see, the conversation is fine. I mean, if I ask a question, it can respond the questions, but it doesn't have the memory of the previous conversation, right? Because the way large language model are designed, they don't have memory, right? The API definitely doesn't have. We have to have the distinction between the chat GPT or Gemini. That, I mean, those are nice tools, and they have added many layers of they have added memory and other stuff. But when we are building application, we are definitely not going to use the chat GPT or Gemini. That's the UI that's available to us. So we're going to use the API, and it's going to directly talk to the LLMs essentially. So it doesn't have the memory, and if it doesn't have the memory, then the conversation will not be effective, right? I mean, we are not gonna type the same thing over and over when we're asking something to a chat, or it can be a customer support, right? So it has to carry those information, it has to carry those previous context. So that's where essentially the idea of memory comes to the picture. For example, if I type over here, hey, do you know me? Let's see what it replies. So maybe let's I need to refresh because the website definitely timed out. So over here, if I say okay, so I'm gonna change this to console chat. If I ask, hey, do you know me? Let's see what it replies. Do you know me? So as you can see, it says, I don't actually know you yet, but I'll have to get to know you better. So if I say its name, hey, my name is Bazlur, and I mean it says it gave me some reply, hey Bazlur, nice to meet you. But if I ask again, hey, what is my name? It has no clue. As you can see, so memory is essential, and how can we achieve that? That's essentially the next demo, which is our step 2. So I'm going to stop this one and then go to the step 2 and start running. So it will take a while it's running. I'm going to explain the code. So over here, additionally, what we have in this length changes services, we had chat models. We already have seen this, right? We added API key and model, all those things. And then additionally, we have a new construct over here, which is called chat memory providers. So there is a few ways to, use this. One is, if obviously we can use in memory chat providers, which is will keep the previous conversation until a point. For example, over here there's a thing called max messages, or that means how many messages we can store. And then if we keep the conversation going, it will remove the oldest conversation, essentially. So over here in this demo, we stored a database. So essentially what we did is we specified the chat memory provider via this construct. We have a message window chat memory provider. There are a few others. And then there is a chat memory store over here, which is essentially a persistent chat memory store. It's an API provided by LangChain4j. And we have a repository over here, which is chat memory repository. It's a traditional JakartaEE stuff. Basically, provided you get an entity manager and then you write all this query, all sorts of things. It's a standard JPA. So I'm gonna skip that part. And what essentially it does is when we write something, it stored those in conversation in a database for this particular demo. That's how we did it. And then when we are gonna, write the next conversation or ask the next question, it will append the previous, conversation to along with it, and it will send to the LLMs so that LLM have the context of previous conversation and give you the reasonable answers. So that's what it is essentially does. So let me see if I can show you the demo over here. So again, the interface is same. I'm gonna increase the font. I'm gonna ask, hey, this is Bazlur, and it's definitely going to reply something. Did I miss anything? So sometime demo goes. Okay, so let me try again. I think something with the website had not been connected. Okay, so this time it connected. Okay, it got connected. Let me ask the same question. Hey, this is Bazlur, and as you can see, it's going to send me says hello again, Bazlur. How can I assist you? And if I ask my name again, hey, do you know me? Yes. As you can see, it says yes. You mentioned earlier that your name is Bazlur. How can I assist you? So essentially, it remembers now, right? Now that if we create a chat service for a, let's say, bookstore, we don't have to frequently remind what we want to ask for it, right? We can have a human to human conversation like this. So that's essentially it. I have to give me a minute. I have got a visitor over here. Just give me a second. Essentially, the chat memory it is. Now, why it is important? I mean, it has many use cases. For example, if we are building a a assistant for the banking system, right? You start with your conversation, you provide all the information, and then you ask the questions. And then if you ask another question, you don't have to provide all this information because it has all those information already there. So that's essentially it is. All right, so that's the demo about the memory. Let me know if you have any questions. Essentially, we didn't do anything additional other than this construct, which is adding a chat memory provider. And the AI service has a builder method called chat memory provider, and then we pass it this construct over here that we created over here. So I'm going to go to the next one if you don't have any questions for this particular one. Okay, so next one is essentially a important one, which is about tools. So let me go to this one first. Am I still audible?
Yes.
Same package. So it's running. So now I'm going to refresh this page. And do you remember, sometimes when you ask some questions to a ChatGPT or Gemini, it says I have a cutoff date. I don't have the real-time information, all sort of things, right? So the model are usually trained on a corpus of text or some collecting information from other places, but it has limitation. It doesn't knows all the information. For example, it certainly doesn't know your private business information, right? You have a lot of policy documents, you have a lot of internal knowledge base, and as a public LLMs or your private LLM, whatever, the LLMs are not supposed to know those information. But for making some decisions, making your business cases, you probably need those informations, right? But if the applications, you design application that requires those information, your local database access, right, doesn't have those.
You're breaking up, Arthur.
Shaaf, do you want to take it up?
I can't hear you. Do you want me to start with the RAG?
No.
Do you
Yeah, let me do that. I'll jump in.
We can hear you just fine.
Okay. I hope you can see my screen now.
Yes.
So yeah, so Bazlur is going to come back to the tools demo. But before we do that, there's something interesting here is when we look at large language models and when we start to mesh data specifically that we have or we need, basically large language models don't have that. So the private data that exist in our organizations, large language models don't have them. Most of them that are being trained do not have them unless we train them, right? But one of the things with large language models is that they will hallucinate, they will make mistakes, and it's really up to us to define that. And a lot of times people will end up saying, okay, I got this response from the large language model, and this is the result, right? But it's not true. Like we see on the demos here, it's not true for every different generation that is done. So yeah, so in this picture, like you can see, I mean, it looks very accurate, but when you start looking at it more further, you see that this person doesn't have all the fingers on their hands. And to the context that, do not mix accuracy with the truth. And it's important that for us that we kind of, as developers, are able to sort of mesh that and keep our checks and balances that we wanna be able to do. So I'll jump in and I'll go into the what is the way to handle this, or one of the ways to handle this, because if a large language model is not trained on knowledge that we need or we have from an organization, the chances of it actually answering that questions is very, very low. For example, if it's insurance domain or banking domain or a bunch of accounts that are specific. So if there's a specific credit card checking account or etc., or a super secret account which can only be opened with $10 million or something, then those information was not, well, it's secret anyways, but that information you won't be able to get out of the large language model, and that is something that will work like that, right? So here, for example, in my case, what we're doing here is that we have step 05. I have a backend database, which is the Postgres database, which we are using. And that's the PG vector database, basically, that I have provisioned here in my Docker Compose file. And then what I'm doing is I'm using Wildfly to do that. I'm also using a nice CLI called Adminer, which just is a basic, very, very basic CLI that gives me the possibility to run queries and look at data. I could also use that in IntelliJ, but I'm used to some of these old tools like some of us. The LangChain service is pretty similar. We have a LangChain service, but then we also have something called a personality expert, because what we're doing with this specific use case today is that that we've created this markdown document, and this document, which is, by the way, created by large language model as well, which is basically just a bunch of personalities, right? So there's somebody called null pointer Nick, which is Lord of Unexpected Errors. There's Singleton Steve. There's JVM Jerry, claims he's once saw the JVM in a dream. There's also AI Alex, etc. Trying to replace himself. So a bunch of just fictional characters. And interestingly enough, these are not going to exist in large language model, even though that a large language model generated these, right? So that's also interesting. So it doesn't have the reference to this. It doesn't have the reference to all of the data that's in there, and that's what we want to enhance the large language model with. So what we do in this specific step is that we have a personality expert prompt, just like we saw the other prompts. And what we're saying is, you're a personality expert. I will ask you about a person, and you will tell who they are in less than one sentence. If you do not recognize the name, you will say, I do not know who this is, right? Try again. I've already started my Wildfly server. So let's say if I go go over here and ask the same question, ask a question like, okay, who is Shaaf? That's my name. And since it most likely doesn't know about me, it's going to say, I do not know who this is. Try again. And my name is not in that markdown document, right? So it's not able to basically get that. But if it was something public, it will most likely be able to get it. How this is, once this personality expert is there, right, what we do is that in our LangChain service, what we've done very simply is add that personality expert, just the same way we did with the other prompts as well, right? But then we've also added something else, which is the embedding store content retriever. And this is basically, once we query from the chat, it is trying to go and retrieve this content from our embedding store. And you see the embedding store is being injected here. So let's take a look at some of those constructs that we have, right? So in the app config, we have the data store, which is the Postgres data store that we're using. We're using an embedding model store. So we're using an in-memory model store that's provided within the LangChain4j setup as well, which gives us the embeddings, which is those numerical identifiers. And then what we are also doing is that we are basically creating how our embedding store should look like, simple, and different embedding stores will have different sort of properties. So here, because it's Postgres, we have the basic dimension, the indexing list, etc. All of these things that are configured for this, and a table that will be called embedding store. Once this basic setup for the application configuration is done, we have the startup bean, and the startup bean, obviously on post construct here, what it's doing is that, coming down here, it's loading the documents from the documents dir that I just showed you the markdown from, but then it's also sort of preparing the ingestion where it's saying, okay, I have the ingester, I have the embedding store, that's the PG vector store, I have the embedding model to create the embeddings from those documents. And then what I'm using is I'm using the document by word splitter, right? So it's saying my max segment size, which is the segment of my words, should be about 50 characters, right? And then they can overlap a bit as well. And because all of this is written back down into vectors or these numerical bindings, you will see how that looks. I'll just show you that in a second. And then finally, what I'm also doing is that we are ingesting the document. So we're calling the ingester and saying, hey, ingest these documents for us. So if I go into my logs, which basically have moved on, but anyways, in the logs, I would also be able to see through this that, okay, how many tokens did I actually use for doing some sort of ingestion on this as well. Before I go on, I want to also show you how that looks. So I'm just going to say command enter here. It should show me their results, but apparently it doesn't. Hang on. SQL command. and select data. So no data. Interesting. Okay. That is a first. Let's do that again. All demos should fail. So let's see how this goes. Okay. And my Wildfly server is starting. Starting deployment, LLM. Yep. And documentation. Deployed. Total documents parsed is 1. Ingestion result is 1088 tokens. So that should be in there. So let's see what did I miss? Okay, perfect. So it's there. Probably something I did. So let's just write an SQL command. Select. If I actually just show you, it's a lot of vectors, and it doesn't look very nice for our eyes. But you will see that there's a lot of this numerical data that's in there, right? So that's not human readable. That's what would be used by a large language model. And there's a bunch of these rows, right? So that's what it is. But if I want to see what is in this embedding, I would go into text and embedding ID from embedding store. And here I should be able to see, okay, so my embeddings are about 50 characters, right? And you can see that they've been they've been divided as such, and then they would have some overlap, which is not visible by us because that's in the numerical checks that we have there, the numerical values, and that's how it's working. So if I go back here and on my on my screen here, if I say, who is AI Alex, right? So it should come say AI Alex is a 30-year-old individual who is trying to replace architect and codes in Java using Vim, right? So it knows that there is something there within that document that it has been able to retrieve, and using the RAG. And how RAG is working is basically it's taking the similarity search from the vector space here, and able to attach that to the request that is made to the large language model. And that's how the large language model knows who, for example, AI Alex is. So here you can see that it says AI Alex is trying to replace while he codes in Vim. But that's not true because basically, it's CLI Cindy that hates GUI and writes all Java code in Vim. AI Alex is trying to replace himself. So the chunk here wasn't really clear, right? So this means that what I did here is not maybe the best way to divide my data because it's not giving me the exact result. So let's take a look at even a worse case than this. I'm just going to write another query here, which is going to be delete from embedding store. And I'm just going to delete. So here it deletes 88 rows, right? So that's gone. What I'm going to do now is that I'm going to go into my ingestion and I'll say, okay, change this max segment size to 5. So we saw that the result was there. It wasn't the best. We are now going to make it even a worse result than before, right? So I'm just going to save this. And yeah, this happens with me sometimes in live reloads. So what we're going to do is that I'm going to rerun the server, but this time you will see that once the embeddings will take place, the size of the embeddings would be different, and the response of the large language model is also going to be very different, right? So let's go back here. I'm going to run this again as it comes up. It is coming up, and yep, it should be there by now. Here. So here, if I ask who is AI Alex, right? So AI Alex is an artificial intelligence entity named Alex. And again, that's not true. Let me just go back to the markdown file just to refresh our memories here. So AI Alex is trying to replace himself with an AI that codes in Java, right? But here, the first response wasn't good enough. The second response is even worse because it's he's trying, it's an entity named Alex. And the reason for that is because if I look at, let's take a look at the embedding store again. And here you'll see that now the text is totally broken, right? So it's not enough to cram the exact amount of words. And this is something that you would need to play over and over again to kind of come up to the right combination of saying exactly what you want. Like my personality expert should know the name of the person, but here null pointer Nick is almost in 4 rows. To actually do the similarity search, this is not going to be easy to get the right vectors from it as well. So we're going to do one more try here, and we're going to try to maybe make this a little better. And here, let's say we say, roughly it's about 200 characters per line, so it actually gets some detail there. I don't necessarily need an overlap, but I'm just going to say, hey, let's take a little bit of overlap as well. So it can work with that. So I'm gonna restart this. Restart the server, and it's gonna load up the documents again. Actually, before I do that, I should delete this because then it's just gonna be multiple embeddings. Let's do that. Like all fun live coding. So here you saw that it's 951 rows this time, right? Because the data was split so much differently last time. So we're going to do this one more time before I hand it over to Bazlur in about 2 minutes, I think. But let me just start the server again. And as it starts, it's going to do the same thing because it's a startup bean. It's going to go through the reins of it and create the embeddings again. So now if I go back to the application and say, okay, let's say, who is AI Alex? And this time, AI Alex is person trying to replace himself with an AI that codes in Java, right? So now it's giving me a much more accurate result because now if I look at select count static from embedding store, you'll see I have 23 rows only, right? And if I say text, you will see that the text is much, much more larger. Again, this is too large, maybe perhaps for my context, because if I start to go in a more crafty prompt, it's gonna be very, very interesting how it's gonna start mixing up these personalities as well. So to come to the final point, obviously there are multiple ways to do this. I just showed you the word part here. You can also do this by sentence. You can also do this by document, so splitting them up. You need to play with your overlap size. You need to play with your max segment size because the overlap size is sort of the similarity between the different segments that it can put up. And obviously you need to know how many tokens that you need to put in as well, right? So that's going to define how your output is going to look. So I'm gonna stop here. If there's any questions, I'll take any questions, and I'll also pass this on to Bazlur. Bazlur, are you there now?
Yes, I'm here. Hopefully you can hear me.
Yeah, I can hear you.
Okay, perfect. Sorry about the interruption. I have a toddler. She's 2 years old and she can burst in anytime. That's what happened. So I needed to cool her down. All right, I'm going to share my screen again. So I was saying about I was about to demo about tools. Tools is the idea is that LLM can, do a function call to access your personal data. I mean, if you are creating an application, that application has a, private informations, for example, database that needs to, invoked. In that case, tools are the great way to do that. Essentially, what it can do is we can specify some functions. For example, over here I have a function called get web page content. The idea is, as you can see, there's the annotation over here. So I have an annotation over here, which is tools. It's provided by the LangChain4j. We can put the description over here. What I say is returns the content of the web page of a given URL. And if I provide the URL, it will fetch the content, and then an LLM will take it over and sort of organize the way I want it. So for example, if I ask, hey, do you know the last article I wrote in my blog, bazlur.ca. So okay, so sometimes it ignores. That's typical. So I'm gonna do it again. So essentially that's another example. So we can specify functions, and the large language model can ignore that as well. It's so let's say we have few functions similar to that, and we can specify those, and then it will definitely use the appropriate one. For example, as you can see, it says the latest article on your blog titled "Chat with Your Knowledge Base and Hands-on Java and LangChain4j Guide." So that's true. That's the last article I have written. But this is because I have written this function over here, which is web-based tools. So if I didn't have, probably it could not do the search. I mean, ChatGPT and Gemini interface can do that because it has all those tools added to on top of the their primary models. But when we're writing our applications, obviously that won't be available, right? So that's an example of tool. How can we use that? And we have a few other tools over here. For example, there is another one which is JakartaEE project generation tool. I'm going to show the demo. Also, I have a Java compiler tools. These are the fun tools that I prepared just to give you a nice demo how far we can do with tool. To add that, we just have to specify them one by one over here. As you can see, we have a specified AI services, and then using the builder pattern, we created the the agents, which is essentially an interface, and you can provide all this system access over here. I think Shaaf already explained that. And additionally, what we did is we added a tools layer on top of it, which is that's inside this method. You can specify all of your tools over here. So this is the web tools that I already showed you the demo. And next one, what I'm going to do is I'm going to demo about the Java compiler tool. So over here, let me explain that what I did. It's a fun one. So what I asked is, compile the provided Java source code and return result in bytecode. The source code should be valid Java code. So the idea is, if I provided a Java source code, it can compile and store them somewhere in the temporary folder. And there is another tool that execute the provided bytecode directory path and the class name. Assume it contains a class with main method and returns the output. So ideally, if I give it a bytecode directory, it will be able to execute and return me the result. And there is another one, which is disassemble the given bytecode from a path and give you all the details about it. So what I'm going to do over here is ask it, hey, can you give me a simple sorting program in Java. Let's see what it does. So as you can see, it's giving me a simple sorting applications. Now I can ask, hey, can you sort of compile it, and let's say run it. So as you can see, it's doing some work. If I go to the log, and as you can see over here, it's invoking the Java compiler tools over here. And this is the message I provided, which is, can you compile and run it? And then you see over here, running class, simple sorting in directory. I have created a temporary directory, and from the temporary directory, it's basically compiling and running. I mean, as you can see, it provided me the result. So the original array was this one, and then it definitely sorted and gave me the result. So this is essentially how we do the tools, and we can also invoke the JavaPE over here. So we can say, hey, can you give me the bytecode of it and explain it. So let's see what it returns. So as you can see, so it's going to use the JavaPE command over here, and then get this bytecode, and then it will create some sort of explanation to it. So yeah. So that's the bytecode, and then it added also some explanation over here. So essentially, what happens over here is I write it, questions. It goes to the LLMs, and LLMs decide to invoke the function. We have this function over here specified, right? And then when function is invoked, it produces some result, and this result goes to the LLM again, and then LLM that then sort of use this result and organize it the way I wanted earlier in my earlier conversations. So and then send me the response. So this is how tools actually useful. And we can also initially at the beginning of the project, I showed you a structure over here, which is start JakartaEE, where you can generate the project using specifying the versions, platforms, all those things. And you can essentially, I have another tools that you can do it using this way as well. So for example, this is a large one. I specified all these um, uh, description over here. For example, in this tool, I have provided all this description, generate a JakartaEE project with customizable configurations. I provide helpful all the, instruction I could imagine. So I provided all of them over here, as you can see, and it requires some parameters. For example, it requires profile, version number, runtime, all of those things. And I also provided this enough description so that LLM can understand which is required. So if I come over here and say, hey, can you generate a JakartaEE project for me? And it will definitely say, hey, sure, let's start by gathering the necessary information to generate the JakartaEE project. So basically it asked me, I needed all this information to generate them. Can you provide them? So I can sort of, provide them over here. So I'm gonna use it. I'm going to use 10, and I want full profile, go with 17, and I want let's say glassfish. Now I provided some information over here, right? So it got those information, but I needed more information over here. For example, I didn't specify Docker support, and then Maven group ID, and also Maven artifact ID, right? So what I can do is I don't need Docker support. I can specify that I don't need Docker support, and then use the REST as default. And so it got all the information it required, I think. So as you can see, your JakartaEE project has been successfully generated. You can download using follow links. So since I provided all this information now, it given me the all the it given me the project over here. As you can see, I can download it. So yeah, so that's how we can use tools, and tools essentially helps in many ways, accessing local informations, business related information, or application specific information. For example, if I need to access database, I can use a tool to access this database, and that's where my next demo is coming. So in the next demo, I'm going to use try to access the local database and see how it works. So meanwhile, if you have any questions, let me know. Let me go to the next steps. It's going to be advanced one. Let me see. The step 8, 08. Okay, so over here, I'm going to run it. Let's see if it works. So essentially, while it's running, I can show you the code, explain the code, what I did over here. I have a repository class over here called book repository. It's traditional, typical entity manager, JPA stuff. I have a database here where I have a list of books, and I can find them, find all categories, find by ISBN, find by, title and or authors, and typical all these methods. And I want them to be accessible via tools so that in the chat interface, while I'm talking to LLM, it can, in fact, invoke those methods. So there is another service over here I have called Bookstore Services, and that's essentially all these tools over here. So it's essentially a wrapper around the repository. So it's a tool where I specified the name, value, which is the description of these tools, right? And then it calls these repositories essentially. So I have all of those over here, searches for books within this specific category. And this is also a search book tools using a query. It's also get by ISBN. I provided all this information so that LLM can understand from the queue, and also I can store them in a card and then see what's on my card. So essentially, the demo is I have a simple bookstore applications over here. As you can see, I have lots of books over here. And obviously I have my own book over here, which is gonna come in September, but you can read in O'Reilly early release if you want. So now I can chat about books in this through this interface. I mean, it will definitely have lots of books. Imagine Amazon, right? In Amazon, it will have millions of books. But what if you want a recommendation from the chat interface? For example, you can ask, "Hey, can you recommend some concurrency books for me?" Let's see what it returns. So it's working. Okay, that's interesting. Let's see what's going on. Probably I misspelled concurrency. Did I misspell concurrency? Okay, it could be. How about some Java books? Let's see what it returns. So okay, so it's found 3 recommendation. It says over here, so it's found 3 recommendation over here using Java. As you can see, it returns 3 Java books, right? And I can. Sorry, I don't hear.
Now it finds the book on concurrency.
All right. So yeah. Let's see. Hey, can you find a book, written by Bazlur Rahman? Let's see if it can find. Sometimes demo works, sometimes doesn't. Okay, it's weird. Last time it certainly did work, but there is a certain uncertainty definitely. Maybe we have to work on that. So yeah, I mean, if I can specify a specific one, that shouldn't be the case. AI should understand uh, what I have. I mean, understand my basic text. So let me see. How about modern concurrency in Java? Let's see what it returns. I mean, if this time it works, okay. Okay, something definitely not working. So probably this search query is blank. Something with this search query. Okay, so never mind. I mean, I can ask now. Hey, I want to add. Can you add add to my cart? And let's see what it says. Okay. So yeah, I have successfully added Java concatenation in practice by Vanguard's Gets and other steward cards. I mean, it's just one. Okay, so that's interesting. I definitely have to look into more about this, search query that probably need a bit of optimization. As you can see, it's already added that in the shopping cart. So if I ask them, hey, can you add more? Can you add 2 more copies of that book? Let's see what it does. And as you can see, it added 2 more copies. Now I have 3 copies over here. So that's how essentially we can use tools to leverage these sort of things. It's directly communicated with our databases. Now this is RAGs. Sorry, this is tools, and we can combine with RAGs as well. For example, in a bookstore applications, there has to be some sort of policies. For example, if you want to return a book, how about I can ask about return policy? Hey, what is the return policy? Policies, right? So this information, this return policy is specific to your organization, your bookstore, right? It shouldn't be the generic one, right? So this information you can feed by the RAG process that we also used over here. For example, in earlier demo, you saw how we can ingest certain documents. So over here, I have I have certain information over here. For example, general informations, list of books, return policies, shipping policies, all those things, and terms and use. So these are ingested through the RAG process, and this is returned from that this information essentially. So this is how you can combine RAG and also the tools and create something interesting, combine those things and make it useful, so that the conversation, the AI itself is also knowledgeable about your internal information knowledge base, and also it can, obviously LLM has more informations about other things, so the conversation will be more fluid and interesting and engaging. So yeah, so that's how we can leverage this sort of tools. Let me know if you have any questions. Otherwise, I'll hit, next one is about MCP, which is really interesting. Everyone is sort of talking about MCP. So that's, Shaaf, I'll hand over to you. I'm going to stop sharing.
Yeah. And like you termed me as the slide guy, so I'm going to start with slide first. Okay, awesome. So basically, what Bazlur showed was quite interesting. We have, it's not the same sequence diagram that I'm showing, but user, large language model, and then tools, right? And this is nice, but assuming that, let's say like Bazlur writes a tool for Slack for his application, and I write a tool for Slack for my application, and then everybody else writes a tool for Slack. I don't know why, but let's assume so. This would mean that, all these tools, they're just like out there, and it's going to be a lot of tools like this that we will all write, and it's replication of effort. With MCP server, Slack could provide the tools for their for Slack, and that would mean that then we can use that to basically enhance our applications as an example as well. So which is interesting, and that's what Model Context Protocol started by Anthropic, and now everybody else is jumping onto that does basically. It has multiple components. It has a server and a client. So I'm just going to do the server part and show you how we've done that. But the idea is that once the user requests or asks a question to the large language model, it's going to invoke the MCP server to actually use the tools that are there as well. So like Bazlur said, the best explanation is in the code. So let's get into the code. What I'm doing here is I'm using the REST backend that Bazlur also builds, the similar thing with bookstore with a little bit of minor changes here. But it's the same thing, it has the same functions like find all categories, SPN, title, save the book, etc. So it's basically having all the functions for the book application as well, right? And the book application is basically exposing its data through the REST API. So if I go here and I say /books, it basically, you can see that it is exposing all the books or the whole REST endpoint through here from all the books. So hopefully I can buy Bazlur book from this interface today. So that's the backend API, and assuming that you're writing a REST API or you already have a REST API, and you want within the organization all the other departments, etc., to be able to consume that within a framework of large language models, then you would use something like Model Context Protocol. At this time, there is no specific Model Context Protocol implementation out there for Jakarta, but in our case, we're using Quarkus, which is also JakartaEE compliant or compatible, as you would say. And what I do in this Quarkus application is that we basically have the books entity, which is going to call as a REST client to the books API. We have the book client, similar, get all the functions, and also be able to update the books, etc. And then finally, also the service that kind of exposes those functions. But most interestingly, we have something called the book tool. And here in the book tool, it's pretty much quite simple. I have a method which says get all books from the bookstore. This tool annotation, like Bazlur showed, is going to be exposed via the MCP server, which is built in Quarkus itself. So I'm using the Quarkus MCP extension, and it's going to basically register all these tools to the large language model. And then what I'm also doing is that I'm just basically conversing with the large language model in pure JSON as well, right? So that's pretty much what I'm doing. What I want to do at this point is be able to build this as an Uber jar. So I've already sort of done that, but I also use something called Goose. And Goose is an MCP client. And Model Context Protocol can have two sort of protocols, right? So it's the standard output, which is just standard in and standard out. And then it also has the option to use SSE as well, right? But here I'm just using the Goose CLI, which is used the standard output. And what I'm doing in this specific command here is in this CLI, because Goose CLI is like I've already configured my large language model, my OpenAI key, etc., into it. What I can do with this CLI is that I can say, hey, I also have these MCP extensions. Would you please add these to the CLI as well? And every time it's going to speak to the large language model, it's going to invoke my extension and method. So it's going to register all these tools within the CLI as well. So that's what I'm doing. And you can see that it's quite simple. It's just using Java jar target, MCP server, which I've created for this, which basically we built for this purpose. And if I look at my resources, I'm actually asking Quarkus to make an Uber jar, right? And then I log all of this over here. So basically asking Quarkus to make sure that everything is within the jar that is packaged here. And then I'm also adding the endpoint detail of my REST API so it knows where it needs to call, where the REST client needs to call this as well. So I'm going to run the Goose session here. Hopefully this will run fine. I'm just going to make this bigger. And now you can see that the Goose CLI is using GPT-4o from OpenAI, and it's using, I'm in my current working directory, and it should have loaded the extension. So if I said get or how many books do you have? So here you'll see that it's going to do an analysis. it's going to say, okay, there is a function called get all books, and you have about 20 books in this. Is there any book on concurrency? And here it's going to go back and say, okay, I have 2 books on concurrency, one Java concurrency in practice and one modern concurrency in Java. And then I can say, who is Bazlur, right? And now this is obviously not in my rack data or anything. Now it's going to try to go, and you can see it doesn't fetch any of my tools here. It goes in and says, Bazlur Rahman is an author known for writing about Java programming, context of bookstore, etc., etc. So it kind of also gets some information from there as well, right? And then obviously it also adds my name. I don't know why it does that, but anyways, I'm happy that my name comes there as well. But let's just assume that it's I wanna buy some of this, right? So okay, I would like to buy Bazlur's book. And now here, obviously, the data that it's getting, it's actually taking my user input here. It's then sending it to large language model. Large language model at this point is saying, okay, I know there's a tool for this. It's sending the control back to my MCP server, which is running within the CLI, and then asking it to invoke that specific tool. So natural language processing plus the API, because API doesn't sort according to this sort of prompt, right? So it's basically combining those 2 things as well. But here you can see that it's not the most funny one, but it knows that it has 2 books, right? So I want to buy a modern concurrency in Java. Okay, so now it's going to execute the tool again, but again, it is smart enough to know, okay, I have a couple of them in stock. This is the book in stock, perfect. I would like to take 200 copies of this, right? So we're going to buy 200 copies of Bazlur's book, but it says, hey, the quantity here is that's too much. Would you like me to make a call and update the quantity? So obviously some things can go wrong, and this is obviously not good, but it says it seems that ordering 200 copies of modern currency exceeds the current stock, as this action has set the stock to a negative. I recommend contacting the bookstore, right? And obviously this wasn't the answer I was getting before, but it's also interesting that it can take the analysis and make the results. But I'm gonna do something different, which I also want to point out here, is that we have to be very careful what we are exposing out to this model context, right? So I would say, what if I want to sell you 200 copies of this book, right? And it's going to come back and probably say, no, you can't do that. Let's see. Yeah, it comes back with a large text and saying, hey, I cannot do that. Facilitate the process, bookstore would provide upon contacting. Okay, I don't want contracting. Can you update the stock by 200 copies, right? And here again, now you see that it's actually updating the stock. And that's my mistake as a developer, to be able to expose that to this, because then it will take that direction and actually do that. And that's how injections can happen. That's how something can creep in. So we need to be very careful of how we do that. So that's a quick and short demo on MCP server part. So here, if I just quickly wrap it up, user asks the large language model analyzes the question, determines which tool to use, and then it basically asks the MCP server to execute the tools. The tools then, after execution, send that result back to the large language model, and the large language model, creates and formulates an answer for the end user based on that. And if it needs to execute an update request, etc., it will also be able to do that. So yeah, so that was a nice short demo on MCP server. And then there's also an interesting part, which is the MCP client. So I'm going to hand over to Bazlur to take us there.
Actually, we run up against our our quitting time here. So we're gonna have to wrap things up, but this has been really helpful.
All
Um,
right.
cool.
Then in that case, I'm gonna skip the demo. Yeah, let's I can just quickly take 1 minute. What do you think, Scott?
1 minute to wrap things up.
Yep. I mean, I'll just show you the point over here. We have we have like, can you see my screen? Okay. I hope you can. I'm not sure if you can, but here, so we have, this is the one which is step 10, where we use, so Shaaf showed the MCP server. We can use over here as a, MCP client. We have these codes over here. As you can see, we have created some tool, clients, but so because of time, I'm not going to show you the demo, but ideally, we have all these steps over here. If you go through from step 0 to 10, you will probably able to, get all those, get pretty much complete idea what are the abstraction, what are the tools available to communicate with the LLM, and how much we can leverage for our particular use cases or applications. For example, as you can see, we shared prompts, memory tools, and also reg, which is a special one. We also have it, steps for multi-models. The idea is you can add multiple models to it. I mean, it can be Olama, it can be Gemini, and it can be Minstrel, all sort of things. I have added like around, different types of models over here, as you can see. So go through this, so go through this source code and try it yourself, and let us know if if you find any difficulties. Please feel free to reach out. Also, we are welcome. If you have a specific requirement, you can create an issue, or you can create a pull request. We'll definitely love that. And yeah, that's it. That's essentially it is. I mean, start from 0 and then go all the way to 10, and hopefully that will cover pretty much all the things that we needed to know to build a Java application with the LLMs. So that's all I had. So thank you for attending these sessions, and hopefully it was useful.
This was amazing. I mean,
It's been great. Thank you.
that's chock full of
Yeah,
information.
great.
Your contact
Yeah,
slide.
yeah, can you put your contact slide up again?
Yeah, we will share the slides as well. Let me just put that up 1 second.
I'll try to have the recording up by tomorrow, and
Yeah, so over here you can see we have source code. You can it's a public repo, so you can access all this demo we have shared over here. And
Okay.
if you want to reach out personally, that's also, we have LinkedIn, all sort of social accounts. So feel free to reach out with any questions. I mean, obviously we'll probably don't know all the answers. But we'll try to help as much as we can. Meanwhile, we will also be able to learn some new things from you all guys. So reach out.
Thanks a lot. This was really helpful.
thank you very much. All
Thank
right,
you.
Thank you.
so I will stop the recording now.